Good morning students. Today we are going to discuss regarding the nuclear models which are very important. Okay, in that we have first one liquid drop model. This liquid drop model is already asked in the previous exam for your seniors. Okay, long answer question, 15 marks question. Okay, so very important liquid drop model. See, today we will discuss only the some important properties of liquid drop model and also merits and demerits of the liquid drop model. Then after we have semi-empirical mass formula. We will ask the question like this: explain the liquid drop model and obtain semi-empirical mass formula. This is the question. Okay, it is a complete question. Today we will see the half of the part of the liquid drop model. In the next class we will see the next part, that is semi-empirical mass formula. Today we will discuss the liquid drop model assumptions, okay, and some analogies between the liquid drop and also nucleus, okay, and merits and demerits, right? So now here liquid drop model. This model is proposed by both. Okay, liquid drop model is proposed by what? Whom? Niels Bohr. Niels Bohr proposed the liquid drop model. See, what is liquid drop model actually? Why these models, nuclear models, came to explain the complete nature of the nucleus. Okay, to explain the complete nature of the nucleus, these models came. Nuclear models. First one is liquid drop model. Second one is shell model. That is atomic shell model. Okay, so liquid drop model. Here we will see the similarities between the liquid drop and also the nucleus. What are the similarities between the nucleus and liquid drop, and what are the some properties which resembles with the liquid drop? How the nucleus is resembles with the liquid drop? What are the similarities between the liquid drop and also the nucleus? Okay, so Bohr proposed the what? Liquid drop model. Okay, here we will see here in the first one, the nucleus is similar to that of the electrically charged liquid drop. First similarity is what? Actually, in general, the nucleus is what? Similar to that of the nucleus is what? Similar to that of the electrically charged liquid drop. Nucleus and liquid drop are same, and the nucleus will take the spherical shape for its stability. The nucleus will take the spherical shape for its stability, right? So, nucleus is similar to that of the electrically charged liquid drop. This is liquid drop, this is nucleus. Both are in same spherical shape. Okay, nucleus will take the spherical shape for its stability. Next one, see, next one is what? Here, the nucleons in the nucleus. The nucleons in the nucleus will move in this spherical shape. Okay, the nucleus will take the spherical shape. The whatever the nucleons, what are the nucleons here? Nucleons are nothing but what? Protons and neutrons. Okay, whatever the protons and neutrons present in the nucleus will move in the spherical enclosure. Within that spherical enclosure, the whatever the protons and neutrons are will move within that spherical enclosure. The second point, this is the second point. First point is what? The nucleus is similar to that of the electrically charged liquid drop. Second one, and it will take the spherical shape. Second one, the whatever the nucleons and whatever the protons and neutrons will move within the spherical enclosure, similar to that of the molecules in the liquid drop. Okay. Next point. Next point is what? The motion of the whatever the molecular motion of the liquid drop or the molecular motion of the molecules of the liquid will gives the temperature of the liquid. Similarly, the molecules of the whatever the molecules, whatever the protons and neutrons, whatever the nucleons move in the spherical enclosure will give the nature of the nuclear temperature. The motion of the protons and neutrons within the spherical enclosure will give the measure of nuclear temperature. Okay, the motion of the motion of the protons and neutrons within the spherical enclosure will give the measure of nuclear temperature. Similarly, the molecules in the liquid drop, the motion of the molecules in the liquid drop will give the measure of temperature of the liquid. Okay, this is the third point. Next we have the fourth point. whatever the nucleons present in the nucleus will be maintain some equidistance, some distance, they will be at some distance, okay, they are separated by a some distance, okay, and that the energy will be distributed totally through the nucleons, okay. The nucleons in the nucleus apart from the అంటే nothing but what, they will maintain some distance. The nucleons in the nucleus will maintain some distance, constant distance, okay. The proton and neutron, okay, or neutron and proton will maintain some constant distance, and the total energy of the nucleus will be distributed among the nucleons, okay. This is the fourth point. Next, fifth point we have, see, whatever the nucleons present in the nucleons present in the deep of the nucleus. For example, this is the complete nucleus. The whatever the nucleons in the middle, in deep, okay, they are attracted from the all other nucleons, all other neighboring nucleons in from all sides. For example, any proton or neutron present in the middle of the nucleus, it will be attracted from all sides of the neighboring nucleons, okay, neighboring nucleons. Whereas the nucleons present on the surface, whatever the protons and neutrons present on the surface will be attracted only from one side, not all sides, okay. This means what? The binding energy of the nucleons in the middle, is more, okay. Whatever the binding energy of the nucleons on the surface will be small. The binding energy of the nucleons present on the surface is small compared to the binding energy of the nucleons present in the middle of the nucleus, because at the middle of the nucleus the nucleons are attracted by all sides of the nucleons, whereas the nucleons present on the surface will be attracted only by one side, not other side. Here all sides, whatever the inside nucleus is attracted with all other nucleons, neighboring nucleons, okay. So the binding energy of the protons and neutrons present on the surface is smaller compared to the binding energy of the protons and neutrons present in the middle of the nucleus. So these are whatever the things, okay. Here we discussed under the Niels Bohr, okay, Next we have assumptions, okay. The whatever the liquid drop model is based on the two assumptions. The liquid drop model is based on what? Two assumptions, okay. What are the two assumptions? First assumption is what? The material of the nucleus is incompressible. It is not compressible. The material of the nucleus is what? Incompressible, and the density of all the nuclei is same. This is the first assumption. The material of the nucleus is incompressible and the density of all the nuclei is same. That is the first assumption, okay. Next one, the nuclear forces. The forces in the nucleus are, first one is what? First one is Coulomb force. Between the protons, and the second one is what? Powerful nuclear force, attractive nuclear forces, okay. These are the two forces present in the nucleus. Coulombic force between the protons and the powerful attraction nuclear forces present in the nucleus. These are the two assumptions. First one is what? The material of the nucleus is incompressible and the density of all the nuclei is same. Second one is what? The forces in the nucleus are, first one, Coulomb force between the protons. Second one, strong, powerful, attractive nuclear forces. These are the two assumptions of the liquid drop model, okay. Next, totally we completed 7 points. Totally we have 14 points under the liquid drop model, okay, along with the empirical formula, semi-empirical formula, right. So these are the two assumptions. Next we have some analogies nothing but what some similarities between liquid drop model and liquid drop and nucleus. Analogies between liquid drop and nucleus. Okay. The first point. Some similarities between liquid drop and nucleus. First one, both are spherical in nature. Okay. The liquid drop and nucleus are spherical. Both are spherical in nature. Okay. Second point, in both the cases, the density is independent of the volume. Okay. In both the cases, nothing but what in liquid drop and in the case of nucleus, the density is independent of volume. The density is independent of volume. Okay, this is the second point. The density is independent of volume. Third one, and in this only, density is independent of volume with some exemptions that the density of the nucleus is independent of nucleus, whereas the density of the liquid drop is depends upon its type. Whereas the density of the liquid drop is depends upon its type. Both are independent. The density of the liquid drop and nucleus is independent of volume, with exemptions that the density of the nucleus is independent of its nucleus, whereas the density of the liquid drop is depends upon its type. Nothing but one for different liquids, it has different values like that. Okay, right. Next, this is the second point, second analogy. Next, third one. Third point is what the molecular attractions of the liquid are short range. Within the short range, the molecular attractions of the liquid will be occur. Similarly, it is applicable for nucleons. The nucleons also attract only for short ranges. Okay, the molecular attractions of the liquid are what within the short range. Similarly, the nucleons in the nucleus also attract in a short range. Okay, this is the third point. Next, fourth point. The surface tension force acts on the surface of the liquid. Fourth point is what? The surface tension force acts on the surface of the liquid, and the potential barrier force will act on the nucleus. Okay, nothing but what? If you take a liquid drop, the surface tension force will be act on the surface. Surface tension force. If you take a nucleus, right, whatever the boundary is called what? Potential barrier. The potential barrier will act on the nucleus. This is the fourth point. And next we have fifth point. Here, the fifth point is, see, when the temperature of the molecules in the liquid drop, increases, what happens? Evaporation takes place. When the temperature of the molecules of the liquid drop increases, evaporation of the molecules, isn't it? When we give the temperature to the liquid drop, what happens? It will be evaporated. It will become vaporization. Okay. Similarly, when we give some external force to the nucleus, what happens? A compound nucleus is formed. Immediately, the nucleons will be emitted from the nucleus. Okay. This process is called what? Nuclear fission. Fission is nothing but what? Splitting of the nucleus into small fragments. Okay. So, when we give a temperature, when we increase the temperature of the molecules of the liquid drop, evaporation will take place. Similarly, when we apply some external force on the nucleus, what happens? It will form a compound nucleus and will immediately emit some nucleons from it. This process is nothing but what? Nuclear fission. Fission is nothing but what? Heavy nucleus will be split into small nuclei. This process is nuclear fission. Okay, what about nuclear fusion? Fusion is nothing but combining of small nucleus into heavy nucleus. Okay, right? So these are the 5 analogues between the liquid drop and nucleus. Okay, next we have merits. What are the merits of liquid drop model? Merits of liquid drop model. Very important one. See, already asked question, merits of liquid drop model. This model is successfully explain the nuclear reactions and nuclear fission. This liquid drop model successfully explains what? Nuclear reactions and nuclear fission property. Okay, and it successfully calculated the atomic masses and also binding energies with good accuracy. These are the merits. What are the merits? It will successfully explain the nuclear reactions and nuclear fission. Second one, it calculated the what? Atomic masses and binding energies with good accuracy. These are the merits of liquid drop model. And what is the demerit? It does not explain some properties, especially magic numbers. These magic numbers we will see in the next class. Okay, it does not explain the what? Some properties like magic numbers. This is what demerit of liquid drop model. So these are the what? First we learned about Niels Bohr model and some assumptions, and also some analogous between the what? Liquid drop model. Okay, and merits and demerits. This is what? One part of the liquid drop model. And the other part is what? Semi-empirical mass formula. We have to calculate semi-empirical mass formula, that will be seen in the next class. Okay, thank you. Watch the video compulsory. Okay, ma, follow all the online classes. This is important class, liquid drop model. Already asked the question for your seniors, so don't miss this. Okay, don't miss this video. And whatever the material I am giving through the WhatsApp, complete the notes within the time and send to me. Okay, thank you.